Okay, so this little video is going to be about cylinder honing. Now, once you've done your rebore on an engine, it leaves the surface of the cylinder quite rough. Here's a little picture to show you what I mean. Depending on the strength of the material, how sharp the cutting tool bit is, it leaves a typical sort of a ripped surface, as you can see there, and it also takes the form of a very fine screw thread that's been pushed through the cylinder bore. It therefore follows that this surface is not ideal for rings to run in or bed in on. So a further process needs to be done to smooth out that surface and to ensure dimensional accuracy so the rings can run and bed in on. Now, that roughness, is no good if you want to seat some rings in on it. So you need to leave the right finish. You not only the right finish, the bore's got to be finished in the right sizes, and it's got to be straight, and it's got to be parallel, and it's got to be round. So the only way to actually finish these bores off properly is to use a process called honing. Now, what I'm going to show you here is nothing new. They've been honing cylinders since time began, and I'm no particular expert on it, but I've just done honing for many years, and I'm self-taught. So I was initially shown by a couple of guys at Dartford Rebore. Neil and Kevin, if you're watching this, thanks very much, because what you actually told me to do works an absolute treat. And I've obviously gone off and added my own experiences to that. So those guys at Dartford Rebore have been honing cylinder blocks since almost time began. So they do a lot, whereas I do a lot less honing, but what I tend to do is I spend a lot more times getting the bores exactly as I want them in terms of tolerances and finish, because I'm not running a business, so I can spend more time to get them just so. The other thing about the process that I use is I use an old-fashioned or old-school approach, which is basically a portable hone. So I don't have a very large, expensive honing machine. I just simply use my portable honer, which again I got gifted from Dartford Rebore. So thanks again to those guys down there, Kevin and Neil, for that. I'm still using the same honer. It works excellent. I now use different stones in it, but we'll cover that later. And I've gone through a number of different drivers for that portable hone over the years, but the intention of this video is just to give you an idea of what I do. Again, I'm no expert, so I've been self-taught pretty much all the way through, so no one's actually stood next to me and shown me how to do this. I've just come up with my own process for doing it. Although when you use a machine, you have got a degree of more control and repeatability, and you also have the ability to oil cool your cylinders, which helps not only with the cutting process and the stones, but oil is critical if you need to finish cylinders at speed, because it controls the temperature, and that is a huge issue when you are doing portable hand honing using no coolant. Anyway, I'll address those issues as we come across. So to do this video, I've got two cylinder blocks here, which have been freshly bored by myself, and one is a plus 60 998 block, which is destined to be restroked to a 1098 crank. It's going to be fitted, so it'll take it up to it's been bored 60, so it'll be 1150 cc once we're done. But I need to hone the cylinders on that. And the other block I've got is the block from the offset boring video, which has been offset bored to 73.5, and now we need to hone those cylinders. So there's some challenges there, or can be some challenges there, depending on how the block is and the tolerances and the position of the bores. Because that can limit how much of the honer that we can actually push through the cylinder and out the end, which could impede our ability to get those sizes exactly as we want them. Anyway, more of that later. So yeah, the purpose of this video is to show you what I do really. and also if anybody else is interested, it's gives them an idea of how I go about it. There's one thing I will say about this is you're not going to do this without the appropriate equipment. Okay, so one of those little hones that you put in with the springy feet and pops out inside the inside the bore is no good for precision finishing a cylinder. You need a precision hone, and unfortunately they cost money. The other thing is you need various sets of stones, so we'll cover that as we go as well, and I'll show you what I use, various grits, and they cost money as well. So none of this is free, and it's not the sort of thing that I would expect the average DIYer to do. You would bring it to somebody like me or somebody who's got a honing machine or cylinder boring equipment to do that for you. But it's just really for an interest, or indeed some of those businesses that are perhaps looking to, especially in the UK now, what with the downturn in some of the engineering shops are reducing their services because of obviously A, the market forces, and B, the potential downturn of the petrol and combustion engine vehicles in the future. So in order to keep the classics running, there's a number of garages are considering, you know, doing this sort of engineering work themselves. So maybe this video might be helpful to you. Anyway, I hope you find it interesting, but let's dig in and see where we go. Okay, let's start off this honing video and look at some of the equipment that we need to be able to do this. So start off with the basics. Obviously dial bore gauge, that goes without saying. That's there to determine the sizes of the bore, and obviously that can't be used without a suitable micrometer. So in this case, with the bores in the 2 to 3 inch range, we use a 2 to 3 inch micrometer. Now, because we're dealing with honing and there's a lot of grit about, I actually use used micrometers, and then I calibrate them myself. And the reason for this is you know, the honing dust, if it gets in that, I don't really care too much about it. But what I do have to do with this is I have to make sure it stays in calibration. So I do check it very regularly. In fact, this is the most checked micrometer I own. Obviously because of the honing grit that can get into it. So in actual fact, its normal use is comparative, i.e. you measure a piston and then you size the bore to it. So actually the size is almost irrelevant. It's the actual clearance over the piston that you're trying to achieve, and that's what you're gauging. So you use this to measure the piston, and then you use the micrometer again to set the dial bore gauge, and then you can use the dial bore gauge to check your progress and while you're honing, and obviously that gives you the wherewithal to be able to determine where in that cylinder you need to remove material. It goes without saying that you need some consumables. So these are the actual stones that go in the honer, which we'll see in a minute. And I use a couple of different brands. There's obviously Sunnen, which most people in the engine building world would know as a major American, you know, worldwide brand. And then there's obviously Della Pina, which is in the UK. And actually, having used both of these stones over the years, both of these brands, I actually recommend the Della Pina ones for using in a dry honing situation. They do cost a bit more money, but I find that they cut and they stay clean during that process of dry honing. So they work a little bit better than these. Having said that, these will work perfectly fine, and I used these for a lot longer than I used these, and it was only when I changed to these did I realise that I found these worked better for me. The other thing you'll notice is we've got different part numbers. So basically, you know, this is just a couple of sets, but I've probably got about 10 or 12 sets in the drawer, and they're all different different grit sizes. So the M27 J45, that's the roughest. Okay, so that's the most coarsest stone, and you can see there's one there that says J45 as well. That's the Della Pina version, and there's a J55 here and a J65 up there. So effectively what I use is I use either well, in fact I use a J45, which is a 150 grit stone, to cut the majority of the meat out of the cylinder, and then I finish the cylinder with a 65. Now where I've got 55s is I used to use 55s for finishing, but now I use the 65. But I've still got these left, so I still use that that size on the small bore while I'm finishing the stones up. It works perfectly well. It's just I now, you know, as time goes on, you start to prefer different things, and I like the 65 finish better. It's certainly in the A series block. So I've still machined more A series blocks with a 55 finish than I have with a 65 finish, but effectively the 65 is a 220 as a 280 grit stone, and that's a 220 grit stone. Anyway, the other thing you'll notice is I've got things like small bore. Well, what I do is I keep stones for different bore sizes. So I have stones for doing the small bore size engines, and I have stones for doing the large bore size engines. And that is so that when the stone wears, it wears into the radius of the cylinder, and, you know, obviously mates in that cylinder properly, rather than swapping between the two. The initial bedding in wastes, you know, waste stone material, and also doesn't cut very nice until it's settled down. So I keep you know, a number of these in different grits for different bore sizes. So that one there is my large bore block. Blocks are 1275s, and all these are for the small bore blocks. So this is my portable honing tool. So there's the honing head. Obviously that is fitted to a shank, which then fits to a turning tool, or you know, a means of powering it. In this case, I actually use a Milwaukee Fuel mixer, cordless, which is excellent. For many years I used various corded mixer drills, and whilst okay, they were all working quite hard, because you know, honing, I find, takes you know, it's a lot of power to actually turn that honing head, and you need something with a lot of torque. In terms of the old mixer drills, they would work fine, but they would run hot because they would be working hard. Even though they're low geared, in actual fact a corded drill needs to be quite large to be able to do that, so a corded mixer was probably just a bit small to do this job. Now what I've found since I've gone to the Milwaukee mixer, and I made up my own adapter shaft, so it threads in there on an M14 thread, and obviously fits the honing head, is I'm able to dial the speed in. So if we look on there, we've got a speed control, and that gives me the ability to get an excellent surface finish, and obviously control that cutting speed via the, you know, being able to control the RPM nicely. So that works well for me. The other thing I've noticed is I do need to use a high output battery. So I use this in conjunction with the Milwaukee Tools M18 high output batteries, and I went for, deliberately chose the ones that have the lowest internal resistance to give me the maximum ability to pull current for them. And what I then find is that this tool runs perfectly for honing operations. And a battery, I have two batteries, so obviously I can run one and have the other one ready to go. And, you know, I would use a complete battery to hone one block. So this is the honing head, and what I've actually done is I've loaded a set of stones in, and for the people who know about honing and know about using this equipment, you'll notice that these are quite well worn, and that's because we're going to hone the small bore block first. And on this size honing head with these stones, if I had fresh stones, new ones, they wouldn't fit in the small bore block. So I have to use you know, stones that have had a little bit of wear before they'll actually fit into the small bore blocks. So that's why I have my stones marked up with small bore and large bore appropriately. The other thing you'll notice is I also mark them up, so which one goes, so I know which one's going what position on the honing head. That means that when I swap stones and replace them for stones for a different block or a different grit, they all go back in exactly the same position. I find this is enables me to change stones and avoid things like vibration or any particular settling in problems that you get with the stones. You can just put them straight back in and go straight into the bore and carry on, you know, as you left off, because effectively they wear to suit, you know, the mechanism that's inside. In terms of the actual honer itself, the size of the stones is just determined by turning that, which is effectively a form of cam arrangement, which then feeds turns a spline on the inside, which then pushes the stones out. And effectively what you've got on these stones, they're basically spring loaded, so they go in and then they push into the wall of the cylinder, which does two things. Firstly, it centralizes, and secondly, it acts as a damper, and also provides a means of providing pressure to stop the head vibrating and make sure the stones stay pressed in contact with the wall properly across the whole length. And also they are consumable, so they wear out in relation to the stones as well. That's the end of part one of the honing video. I hope you like that. As ever, please like, subscribe and share, and I'll see you on part two very soon. Thank you very much.